Laws of exponents. So there are many rules with exponents, and we're just going to kind of go through all of them, or like the common ones, and give some examples. So the first rule is that any number to the first power is just equal to that number. So an example of this would be like 6 to the first power simply equals 6. The next rule is that any number to the 0 power equals 1. So 7 to the 0 power, just going to equal 1. Because if you think about it, it's to the 0 power, that means it's multiplying by itself 0 times. So that's going to equal just 1. It's just the identity, essentially. So, in our next one, we have any number to the negative 1 exponent is simply going to be 1 over itself. It just kind of flips it so it's in the denominator. So if we have like 5 to the negative 1 power, this simply equals 1 over 5. Likewise, another example would be if we had 3 to the negative 2 power, that's going to be equal to 1 over 3 squared. So you can see how that just flips over. The next one we have is any number to one exponent times itself to another exponent. You're simply going to add those exponents. So x to the m times x to the n equals x to the m plus n. So if we have 2 to the third power plus 2 to the fifth power, that'll give us 2 to the eighth power, because you just add them up. Our next example, we have x to the m divided by x to the n is going to equal x to the m minus n. So you're going to have division turn into subtraction. So an example of this would be like 3 to the fifth divided by 3 to the third is going to equal 3 squared, because 5 minus 3 gives us 2. If you actually write these out too, they make a lot more sense, because you can see how things will cancel between numerators and denominators. Our next rule we have is x to the m in parentheses times n. So you have like something to an exponent and all of that to an exponent. You're going to do multiplication, so that's just going to be x to the m times n. So if you had 3 to the 7th, all of that to the third, you're going to get 3 to the 21st, because 7 times 3 gives you 21. Next we kind of have a distribution of exponents, or powers. So we have xy to the n power equals x to the n, y to the n. So if we have 2 times 3 to the fifth, that's going to equal to 2 to the fifth times 3 to the fifth. Next, we have x divided by y to the n. And that's simply going to distribute basically the same way, where it's going to equal x to the n divided by y to the n. So an example for this would be like 2/3 all to the 4th power is going to be equal to 2 to the 4th power divided by 3 to the 4th power. And the last one we're going to look at today is x to the m divided by n, so that is a fraction in our exponent, is going to equal the nth root of x to the m power. So whenever we have fractions, our numerator of the fraction is like our exponent still, and our denominator is going to be like the root. So if we had x to the 2/3 power, that's going to equal the cube root of x squared. You can also rewrite this a little differently and have the cube root of x and have all of that squared, because you can take exponents and roots and kind of interchange their order. So real quick, let's do some simplifying exercises to use some of these rules. So we have x to the 1/2 to the 6th power. So that is our rule where we have something to an exponent to another exponent, and in that case we do multiplication. So that's simply going to equal x to the 3rd power. You can kind of look at this because we also know that x to the 1/2 is like the square root of x. So that's the square root of x times itself 6 times. And we know that when you have two of them multiplied together, it makes 1, right? And we end up with 3 x's over here, or x cubed. Another example we have is x to the negative 2/3 power. So whenever we do this example, we're going to get 1 over x to the 2/3 power. But we can simplify it even more because we know that that's a fraction, so we can make that into a root. So it's going to be 1 over the cube root of x squared. And lastly, we have, simplifying this one, x to the 0 power times x squared to the 3rd power divided by x squared times x to the 1/2. So first off, we know x to the 0 power is going to equal 1. Anything to the 0 power equals 1. So we have 1 times x squared to the 3rd. We have one exponent to another. We're going to multiply those. So we have x to the 6th power now, because 2 times 3 is a 6. And we're going to divide by x squared times x to the 1/2. Well, those are multiplied together. So, since they're multiplied, we know we're going to add them, right? So, whenever we add exponents, we're going to have x to the 2 1/2 power, or in our case, we're going to just call it 5/2 power. So, we can essentially just pretend our 1 doesn't exist there, because 1 times anything gives us itself. And then we'll get x to the 6th power divided by x to the 5/2. When we have division, we know that becomes subtraction. So we'll have that is equal to x to the 6 minus 5/2. And that's going to equal x to the 12 divided by 2 minus 5 divided by 2, just putting common denominators up here. 12 minus 5, we're going to get x to the 7/2 power. So, we can go ahead and rewrite this as a square root too, if we feel like it. This is one way to do that, and hopefully these laws of the exponents will be useful.